Hello and welcome to Mr. Tompkins Ed Tech. In this video I'll identify the top 10 most likely topics you'll encounter on a calculated paper and run through some of the typical exam questions to help you prepare for that paper. There is a worksheet that goes with this video and I strongly recommend that you try the questions first yourself before watching. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations. And let's get into it. So first up, let's take a look at standard form. Now when you write a number in standard form, you need to write in the form a times 10 to the power of n, where this a here is called the mantissa, if you want to know the real name for it. And the mantissa value needs to be a number between 1 and 10. Can't actually be equal to 10. It's got to be like a one digit unit value. It can be decimal, of course. And then the next part over here, the 10 to the n, is called the exponent. The value of n needs to be an integer, basically. So n is an integer. That's a symbol for an integer, if you wanted to know. So n is an integer, has to be like a positive or negative whole number, and a needs to be a number between 1 and 10. So write 0.00097 in standard form. Okay, very small numbers are going to have a negative power of 10, and the way I usually do, I just count the number of zeros in front of the first digit like that. So that's got like 4 zeros in front of the 9. So I just use that, and then I write down the digit part with the decimal point after the first digit, 9.7, and then times 10 to the 1, 2, 3, 4. So it's going to be 10 to the minus 4 like that. Okay, so the number of zeros at the beginning is the number you're going to get up there, and the mantissa part here is just going to be those numbers with the decimal point in between them. Right, part B, write down 3 times 10 to the 5 divided by 4 times 10 to the 3. When you've got a quotient like this, where you've got numbers in standard form on top and the bottom, then divide like with like. We're going to divide the mantissas with the mantissas, and we're going to divide the exponents with the exponents. Okay? So 3 divided by 4, that's 3/4, or 0.75 as a decimal, isn't it? Okay, so that's 0.75. And 10 to the 5 divided by 10 to the 3, numbers with the same base, you subtract the indices, don't you? So 5 take away 3 is 2. So I get 0.75 times 10 to the 2. Now this question is asking me to write this as an ordinary number. So let's evaluate it. So 10 squared is 100, isn't it? So 0.75 times 100, what's that then? 0.75 times 100, that is 75. So that's my final answer. Okay. Now again, I've got two numbers here in standard form that I'm multiplying together. And again, I'm going to do the same thing. We're going to multiply like with like. So we're going to multiply the number part with the number part. I'm going to multiply the exponent part with the exponent part. So 2 times 8, that's 16. And 10 to the 6 times 10 to the 4, two numbers with the same base, add the indices. That's going to give me 10 to the 10. Now I've got a similar problem here in that 16 is not a suitable mantissa, is it? It's not a number between 1 and 10. But if we divide it by 10, if we take 10 out of it, we're going to get 1.6. It's 1.6 times 10 is 16, isn't it? What we're going to do with that extra 10, we're going to roll it into the exponent part, so I get one more 10 in my block of 10s at the end there. So 16 times 10 to the 10 becomes 1.6 times 10 to the 11. Part B, well, this is very similar to the one we've just done, so divide 2 by 8, what's that? 2/8, 1/4, that's 0.25. Dividing 10 to the 6 by 10 to the 4, that is going to give me 10 to the 2. Now this time it wants me to write it as an ordinary number. So 10 to the 2, that's 100, isn't it? Okay, 100 times 0.25, that's just going to be 25. Okay, 25. Question 3, work out 2 times 10 to the 14 divided by 8 times 10 to the 9. Another very similar question. 2 divided by 8, that is 0.25. 10 to the 14 divided by 10 to the 9, that's given us 10 to the 5. And again, that isn't a suitable mantissa. I'm going to borrow a 10 from my 10 to the 5, make it 10 to the 4, and multiply my 0.25 up by it. That's going to be 2.5 times 10 to the 4. And then part B says 6200.07. That is equal to 6.2 times 10 to the C and 7 times 10 to the D. Okay, well, I suppose we could say that 6200.07 is 6200 plus 0.07 then, isn't it? Okay, so writing those two numbers in standard form, 6200, take the digit part, 6 and the 2, going to write it as a mantissa, 6.2, and that's going to be multiplied by an appropriate power of 10, isn't it? Now if the decimal point started here and we want to move it there, we're going to move it 3 jumps, aren't we? So it's 10 to the 3. Another way of thinking about it is the thousands has got 3 zeros, it's 10 to the 3. 0.07, so remember earlier we were counting the number of zeros in front of the first digit, so I've got 2 there. So I think this is going to be 7 times 10 to the minus 2 because I've got 2 digits. And so C is the power of my 10 on the 6.2, so that's 3, and D must be my power of 10 on the other one, it's minus 2. Moving on to calculating in terms of pi, don't forget your two most important formulas for this one, for circumference and area. Cherry pie delicious, apple pies are 2, C equals pi D, A equals pi R squared, they're the main formulas you're going to use. Here is a quarter circle of radius 6 centimeters. Work out the area of the quarter circle, give your answers in terms of pi. Okay. Well, the area of a quarter circle is going to be 1/4 of the area of a circle, isn't it? So it's going to be a quarter of pi r squared. Here the radius is 6, so I'm going to get 1/4 of pi times 6 squared. 6 squared is 36, divide it by 4, 4's into 36 go 9 times. So that ends up being 9 pi. And that's my answer. We're always going to give it in terms of pi on the calculated and non-calculated paper because I don't want you multiplying through by 3.14 whatever. So yeah, you just leave your answers as a multiple of pi. So 9 pi is our final answer. Question 5. This semicircle is a radius of 5 centimeters. Work out the perimeter of the semicircle. Give your answer in terms of pi. Okay. So perimeter is the distance all the way around the shape. And for a semicircle, the perimeter is made up of 2 parts, isn't it? You've got like the arc here, which is half a circle, half the circumference of a circle, and you've got this straight line part here, which is made up of 2 radii. Okay, so the perimeter part then, the yellow part is going to be half of the circumference of the circle. So we can use either pi d, but we can also use 2 pi r, which might be better in this case. So it's pi times 2 pi r. And then we're going to add on 2 lots of the radius, which is the green bit. Okay, so the green bit is 2r, it's radius and radius, and the yellow bit is half of 2 pi r, the circumference of the circle. Okay, so let's just tidy that up a little bit. Half times 2, well, they just cancel each other out, but we know r is 5, so that's going to be 5 pi from the first part, plus 2r. Well, 2 lots of 5, that's 10. Okay, so 5 pi plus 10, that's my final answer. Question 6, 4 identical circles just fit inside a square as shown. Work out the area of the shaded section, give your answer in terms of pi. Okay, so this is a bit like a compound area problem. You've got a square shape and you've got 4 circular holes punched out of it. Okay, so to work out the area, the combined area, is going to be the area of the rectangle minus 4 lots of the area of a circle then, isn't it? Okay, I just tend to do a little notation like that so I don't confuse myself. So let's just work out those two areas. So the area of the square part first. Well, square formula is just L squared, isn't it? Length times length. And the length there is 12, so it's going to be 12 squared. That's giving me an area of 144. And then the area of the circle, that's just going to be pi r squared, isn't it? So what's r here? So you can see it's 12 centimeters all the way across, so that's the same as 2 circles. So that means one circle, it must be half of that, it must be 6. And the radius is going to be half of that, it's going to be 3, isn't it? So the area of one circle is going to be pi times 3 squared. 3 squared is 9, that's going to be 9 pi. Okay? So now we've worked out the various bits, we can put it into our kind of master area formula down here. So area of the square we worked out to be 144, and the area of the circle is 9 pi. So I'm going to get 144 minus 4 lots of 9 pi. 4 9s are 36, so that's 144 minus 36 pi. Okay, again, I can't really evaluate that any further other than working out what pi is and multiplying it through, but I'm not doing that, so that's my final answer. Inequalities next. Inequalities solve exactly the same way as equations. So if you know what to do, if there was an equal sign in between these things, you do exactly the same thing if there's an inequality symbol. So we just need to try and get all the x's on one side and get everything over to the other side and evaluate it. Okay, so first up, I've got a bracket on the left with a number on the outside. Now normally I just double check if I can't just divide that number outside the bracket over on the other side, but I can't. I can divide 4x by 2, but not 4x minus 1, doesn't work. So in this case, it's going to be easier just to multiply out these brackets. So 2 lots of 7x is 14x, and 2 lots of 3 is 6, so that gives me 14x plus 6, and that is less than 4x minus 1. Okay. Now, you can then either think about this as subtracting 4x from both sides, that's one way of thinking about it. The other way is change sides, change signs. Another way of thinking about it is moving things over the equal sign. One side, if they're positive, they move over, they become negative. I kind of think of it that way. I think it's slightly quicker to do it that way. So 14x minus that 4x is going to give me 10x on the left. Similarly, if I take 6 away from both sides, or if I take this plus 6 and move over the inequality symbol, it's going to become minus 6 on the other side. Combining that with the minus 1 is going to give me minus 7. So I've got 10x is less than negative 7. Dividing through by both sides by 10, I'm going to get x is less than negative 0.7. Okay. Question 8. Solve negative 3x is greater than 6. Now beware here, there's a trap. Okay, because I've got a minus sign in front of the x. And inequalities behave really weirdly when with negative numbers. Now there are 2 ways to approach this. Either you just avoid dividing through by negatives, and you can do that by, if your unknown is negative, just shift it over to the other side of the equation, make it positive. So switching these 2 numbers around, so adding 3x to both sides, or change sides, change signs with the 3x, I'm going to get a plus 3x on this side, and doing the same thing with the 6, either taking it away from both sides or just change sides, change signs. I'm going to get minus 6x is greater than 3x. Now, to get x, I can divide through by positive 3. That's no problem at all. I can just go ahead and divide, and that gives me x is less than negative 2. Okay, so that's one approach, just simply avoid doing it. The other way of doing it is just remembering if you divide through by a negative number, you have to switch the inequality around. Okay, so I could just divide through here by negative 3 on both sides. Okay, so that would give me negative 3 divided by negative 3 would give me positive 1, or just x. 6 divided by negative 3 would give me minus 2, but I have to remember if I do that, I have to switch the inequality symbol around like that. Okay, so either avoid doing it or remember to switch your inequality symbol around if you divide through by a negative. Okay. Question 9, work out all the integers that satisfy the inequality 8 is less than 2n, which is less than or equal to 16. See, I've got 2n in the middle. It'd be much nicer if I just had an n in the middle, and I can do that by just dividing all parts of the inequality through by 2. So 8 divided by 2 is 4, 2n divided by 2 is n, 16 divided by 2 is 8. So that tells me that n lies between 4 and 8. So you imagine it on the number line, 4, 5, 6, 7, 8, then you'd have one of these things going from 4 up to 8, wouldn't you, to show it? And because 8 is part of the range, we fill it in, and because 4 isn't, because n has to be strictly greater than 4, it's left open. Now we want the integer values that satisfy those. So which integer values are between those two limits? Well, 4 isn't, because 4 can't be. It has to be greater than 4, but 5 is, 6 is, 7 is, 8 is as well, because n can be less than or equal to 8. So it's those 4 there. So my answers are going to be 5, 6, 7, and 8. Okay. Question 10. N is an integer. List all the values of n such that -1 is less than or equal to n plus 3, which is less than 5. Okay. Now again, at the moment I've got n plus 3 in the middle. Now I can simplify that and get n by subtracting 3 from all parts. So take 3 away from there, take 3 away from there, take 3 away from there. These ones in the middle will cancel, just leaving you with n in the middle. On the left hand side, you're going to get -1 minus 3, which is -4. And I've got 5 take away 3, that is 2. Okay, so again, just imagine that on a number line. So if I've got -4, -3, -2, -1, 0, 1, 2, then this time the left hand limit is part of my inequality, so I can fill that one in. My right hand limit has to be strictly less than 2, so that one is left open. So again, what are the integer values that lie between those two limits? My 4, my -3, my -2, my -1, 0, and 1. These are all fine, so I'm going to include those. I'm not going to include 2, because it needs to be strictly less than 2. Okay, so it's those. Question 11, -17 is less than or equal to 4x plus 3, which is less than 11. Slightly more complicated in the middle, got two steps to make it just x. First, take 3 away from every part. That's going to give me -20 is less than or equal to 4x, which is less than, also strictly less than, which is less than 8. Okay, and then dividing everything through by 4, I'm going to get -5 is less than or equal to x, which is less than or equal to 2. Now this question doesn't want us to faff around with finite integer values, so that's just my final answer. -5 is less than or equal to x, which is less than 2. Part B says work out the product of all the integer solutions to -17, which is less than or equal to 4x plus 3, which is less than 11. Oh, they do want us to faff around with finite integers after all. So again, I'm just going to imagine our... Well, we've already simplified it down to -5 is less than or equal to x, which is less than 2. So imagine that as a number line again. -5, -4, -3, -2, -1, 0, 1, 2. Put in a filled circle at 5 because it's greater than or equal to 5. And an empty circle at 2. Okay, so what are the values that match? -5, -4, -3, -3, -2, -1, 0, 1. Okay, you might be thinking, I don't want to spend time doing all that number line business, but I do think it gives you a little bit of clarity and oversight, and helps you avoid making silly mistakes. You know, you've got plenty of time to do this paper. You don't have to rush. It's easy to make little mistakes with these sort of things. So just to visualize it like that just helps you prevent you making those silly mistakes. Oh, now I just reread the question, and it says work out the product of all the integer solutions. The product is multiplying them all together, isn't it? So if I'm going to multiply all these together, -5 times -4 times -3 times -2 times -1 times 0 times 1, that's going to give me 0, isn't it? Because anything that's got a 0 in it basically is going to give you 0. So because it's got a 0 there, I know it, so I don't have to worry about the rest of it. It's going to be 0. Okay. But yeah, just Just top tip, always read through the question again before you move on. Just check you've answered it correctly, because I almost moved on without actually answering that question. And that would be a silly place to throw a mark away. Yeah, so reread a question before you move on, top tip. Next up, expand and factorise, like putting brackets in, taking brackets out, that sort of thing. So first up, I've got factorise x squared plus 7x plus 10. This is a quadratic. Quadratics always factorise into two brackets like this. Now, to work out the contents of the brackets, I normally start with the bit on the end, and I think about the factor pairs of that number. So what are the factor pairs of 10? Got 1 and 10, you've got 2 and 5. Not a lot of choices there. And then once I've got the factor pairs, I then think about, well, which factor pair is going to deliver me that 7 in the middle? It's this pair here, as it's the 2 and the 5. 2 plus 5 is 7, so that must be the pair I need. So I'm going to get x plus 2x plus 5. Does it matter which way around they go? No, it doesn't. Next one, factorise x squared plus 9x plus 14. Going to do it the same way. I know it factorises into two brackets. I know it's got something to do with the factor pairs of this 14 here. What are the factor pairs of 14? It's 1 and 14, 2 and 7. Which one of those pairs is going to deliver me 9 in the middle? It's those two, isn't it? It's the 2 and the 7. So I'm going to get x plus 2, x plus 7 as my two brackets. Question 14, factorise 4x squared minus y squared. Now this one is commonly known as the difference of two squares. This is a square, this is a square, and this mathematically is the difference, so it's the difference of two squares. Okay, now difference of two squares always factorises into two brackets. The identity that I think about is a squared minus b squared is equal to, or is identical to, I should say, a plus b, a minus b. Okay, now notice that a is the square root of a squared, b is the square root of b squared. So my two things in the brackets are going to be the square roots of those two terms that I've got at the top there. So what's the square root of 4x squared? Well, root 4 is 2, root x squared is x. So I'm going to get 2x and 2x at the front of my brackets. And at the back of the bracket, then, what's the square root of y squared? It's y, so plus y minus y. Okay, so I'm going to get 2x plus y, 2x minus y as my solution. Question 15a, expand and simplify 2x plus 1, x minus 2, going the other way this time, removing the brackets. There are different ways of doing this. First, outside, inside, last, two eyebrows, a nose and a mouth, or you can do it as a grid. If you're not very good at doing this, I might suggest you do it as a grid, because it helps you work out what all the values need to be, and you won't miss one out. So 2x times x is 2x squared, x times 1 is x, minus 2 times 2x is minus 4x, and 1 times minus 2 is minus 2. Okay, so putting it in a grid like that ensures that you won't miss one of the terms off, which is the most common silly mistake that students make when multiplying out double brackets. Notice that you get one term which is in x squared, so then this is going to be equal to 2x squared. You're going to get two terms in x along the middle here. I've got x and minus 4x. I need to add these together, so x plus minus 4x, that's minus 3x. So I'm going to get 2x squared minus 3x, and then on the end I'm going to get this number down here, minus 2. Okay, minus 2. So 2x squared minus 3x minus 2. Part B says factorise fully 3x squared minus 48y squared. Okay, now again, if I just bring up my difference of two squares identity, we said that we need to square root the two terms, don't we? The two squares. This is a square, this is a square, this is a minus sign in between them, or a difference of them. So it is the difference of two squares. It's going to factorise into two brackets. But before I do that, I've noticed that 3 and 48 have got a common factor. So I'm going to factorise those out first, and it should make then finding the difference of two squares a little bit more simple. So if I factorise the 3 out first, I'm going to get 3 lots of x squared minus 3's into 48 goes 16 times, and don't know. So I'm going to get x squared minus 16y squared. Okay, and then using my identity, I just need to square root those two squares that I'm finding the difference of there. So the square root of x squared is x, and the square root of 16y squared is 4y. So I'm going to get two brackets, x plus 4y, x minus 4y, like that. So that's my final answer, 3x plus 4y, x minus 4y. Question 16, factorise fully 144 minus 4x squared. Now again, going to factorise out 4 first, make it a whole lot easier then to do the difference of square part. So 4's into 144, what's that then? 40, 80, 120, so 30 and 24 divided by 4 is 6, so 36. So it's going to be 36 minus x squared. Well, luckily 36 is a square number, so square root in 36 is going to give me 6. So 6 plus x, 6 minus x is the solution to that one. So 4 lots of 6 plus x, 6 minus x. Okay. Question 17, write 2 lots of 7x plus 4 minus 4 lots of x plus 6 plus 1 in the form a plus bx plus c. Okay. So here I need to kind of multiply everything out, get rid of the brackets, and then put brackets back in again. Make your mind up. Right, let's do it then. So 2 lots of 7x and 2 lots of 4, that's 14x plus 8. Multiplying out the second bracket, just take care because that's minus 4x. So minus 4x times x is minus 4x, and minus 4 times 6, that's minus 24. And then I've got plus 1 on the end. Okay? So collecting like terms, what have I got? I've got a term in x there and in x there. So 14x minus 4x, that gives me 10x. And I've got an 8, a minus 24, and a plus 1. So 8 plus 1 is 29. 29 from 24 would be 15. So it's going to be minus 15, isn't it? So 10x minus 15. Is that in the form a lots of bx plus c? Not quite, but I can see that 10x and 15 both have a common factor of 5. So taking the 5 out, that's going to leave me with 5 lots of 2x minus 3. That is in the correct form, so that is in my final answer. 5 lots of 2x minus 3. Question 18, expand and simplify 2x plus 1, 3x minus 4. So multiplying out brackets again. I'm going to do it as a grid method. Don't have to do it as a grid method, but if you drop a term, that's on you. Okay, if you do it in the grid method, you won't drop a term. So 3x times 2x is 6x squared. 3x times 1 is 3x. 2x times minus 4, that's minus 8x. And minus 4 times 1, that's minus 4. Okay, so again, going to get one term in x squared there. That's 6x squared. That goes at the front. I've got 2 terms in x. I've got 3x and minus 8x. So adding those together, it gives me minus 5x. And then I've got that minus 4 on the end. Minus 4. Okay. Factorise 6x squared minus 2x minus 4. Again, I know it's going to factorise into 2 brackets like this. It's a little bit more complicated though, because I've got that 6x at the front. Okay. Now 6x could be 6x and x. It could be 2x and 3x. Could be either of those combinations. So when we're thinking about our factor pairs and thinking about numbers, we need to be thinking about those different possible combinations. So it could be 6x and x at the front, or it could be 3x and 2x. Okay. Other than that, again, I'm just going to do it like I did before. I'm going to take the number on the end. I'm going to think about what the factor pairs are. What the factor pairs are 4, 1 and 4, 2 and 2. Okay, so how am I going to get minus 23 out of those numbers? Okay, well, it's going to quite a big number, isn't it? So I'm going to have to kind of multiply the bigger number with the bigger number. So let me look at the 3x and the 2x first. If I put the 2 and the 2 here, that's never going to work, is it? I'm not going to get anywhere close. Okay, if I put the 4 there and the 1 there, then 3x times 4, that's 12x. Again, I'm not going to get close to minus 23, so it's not this way round. Let's try the other one, 6x. 6x times 4, that's close, isn't it? 6x times 4 is 24x already. Okay, so if I put a minus sign in front of it, that would be minus 24x. And then if I multiply 1 by x, that's going to be a positive x, and minus 24x plus x is minus 23x as required. So it's that way round, and it's 6x plus 1, x minus 4 as my final answer. Okay, so if you've got a lead term here, so a lead coefficient here, think about what the possible combinations are at the front. Find your factor pairs and just try them in all the brackets until you find a nice one that fits. That is my advice, simplest way of doing it, in my opinion. Okay, well, expanding and Factorise is going to carry on being helpful for this next section, solving quadratics. When x squared equals 16, the only value that x can be is 4. Is this true or false? Tick a box. It's false, isn't it? Because when you square root something, you're going to get a positive and negative solution, aren't you? So square root of x squared equals the square root of 16. So x is going to be plus or minus 4. So there are two solutions. Okay, I think that's good enough. Question 20, solve x squared minus x minus 12 is equal to 0. So we're going to start off like we did earlier by looking to see if we can factorize first. So does it factorize into two brackets like this? Let's take that number on the end, 12. Let's think about the factor pairs of 12. 1 and 12, 2 and 6, 3 and 4. Now which combination of those is going to give me a minus 1 in the middle? Okay, well these two are only 1 apart. So if I make 1 negative and 1 positive, then I'm going to end up with negative 1 in the middle, aren't I? I'm going to have to make the bigger one the negative 1, so I end up with a negative number overall. So x plus 3, x minus 4 is going to be equal to 0. Now if you've got two brackets multiplied together and give you 0, then one of those brackets must be 0 to start with, because that's the only option, isn't it? Two things multiply 0, one of the things must have been 0 to start with. So if this first bracket here was equal to 0, then if x plus 3 is 0, then x must be minus 3. Or if this bracket is equal to 0, if x minus 4 is equal to 0, then x must be 4. So that 4 take away 4 is 0. So my second solution is x equals 4. So just take note, in the factorized form and the final answer, the signs flip over, don't they? So x equals minus 3, x equals 4. Question 21, circle the two roots of 2x plus 3, 5x minus 2 is equal to 0. Again, let's look at this one here. If 2x plus 3 is equal to 0, if 2x plus 3 is equal to 0, then 2x must be equal to minus 3, so x must be minus 3 over 2. So that's one of them. I need to find the other one. If I've got 5x minus 2 is equal to 0, that means 5x is equal to 2, x is equal to 2 fifths then, so it's that one there. So it's those two. 22, solve the equation 5x squared plus 14x minus 24. Now I have a lead coefficient of x squared here, but because it's prime, if it factorizes, it's only one way it's going to go, isn't it? And that's 5x and x. So, 5 has only got two factors, 1 and 5. So that makes things easy. Let's have a look at the other number, minus 24. So let's think about the factor pairs of 24. That unfortunately has lots of factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So it's going to be one of those pairs. Now it's a slight complication because one of them has to be multiplied by that 5x. And I need to get 14 in the middle. So it's a matter of trial and error. Going through, putting the numbers in and seeing which one works. Okay? Now if I put the 8 here and the 3 here, that doesn't work, does it? So 5 8s are 40, 3, it's not going to get me down to 14. I'm too far away. The other way around. 3 lots of 15, 3 lots of 5 is 15, and 8, that isn't going to get me to 14x either. I think it's the last possible pair. The 4 and the 6 must be those two. So how can I use those to get 14? Well, if I put the 6 here and the 4 here, and I made this one positive, then 6 times 5 is 30. And if I made this one negative, that doesn't work. That gets me to 26. What about the other way around? So if I put the 4 here and the 6 here, so that's going to give me 5 times 4 is 20, minus 6 times 1 is minus 16. That will work. Okay, so it's that combination. Took me a time to find that one, but that's kind of how you have to do it. You have to just try different pairs in different positions until you find the pair that works. Okay, quite tricky that one. 5x minus 6, x plus 4. Question 23, the area of the rectangle is 8 centimeters squared. Work out the value of x. Okay, so area is length times width. So the area of this one is going to be the length, which is 3x plus 1, times the width, which is 2x plus 5. Okay, so we've got a pair of double brackets. If I'm going to multiply those out, so if I've got 3x and 1 and 2x and 5, 3x and 2x is 6x squared, 2x and 1 is 2x, 3x and 5 is 15x, 5 and 1 is 5. Okay, so I've got a term in 6x squared. It's going to be 6x squared. I've got two terms in x. I've got 15x and 2x. That makes 17x. And I've got a 5. Okay, so plus 5. And that is equal to 8, I'm told. Okay, so just taking 8 off both sides, I'm going to form an equation equal to 0 then, aren't I? So that's going to give me 16x squared plus 17x minus 3 is equal to 0. This is going to be a tricky one to factorize. So I've got a lead coefficient of 6x squared on the front. So again, I've got two possible pairs it could be. It could be 6x and x, or it could be 3x and 2x. Don't know which one it is just yet. I'm just going to try both and I'll cross out the one that doesn't work. Okay, so but the number on the end is a prime, so that makes things easier. It can only be 1 and 3. So I'm just going to try 1 and 3 in different combinations in those two brackets until I can work out a way of getting 17. I think I've seen it already. If I put the 3 in this one here, so I'll get 6x times 3, it'll give me 18x, and I put like a minus 1 there. That 18x, take away that 1, be 17x, so it kind of works that way around. Okay, so I won't need that one. So it's 6x minus 1, x plus 3 is equal to 0. So then take one bracket at a time, make it equal to 0, see what the value of x is. So if 6x minus 1 is equal to 0, then x is going to be 6x is going to be 1, x is going to be 1/6, and if x plus 3 is equal to 0, then x is going to be minus 3. Okay. Now those two numbers are definitely solutions to that equation that we had, but not both of them. But both of them are not solutions to the problem. And the reason for that is this is a problem steeped in shape and space and geometry. And imagine x is minus 3, then this side over here is going to be two lots of x. That's minus 6 plus 1. That means this side would be minus 1 in length. This one over here would be 3 times minus 1, minus 9 plus 1. That'd be minus 8. Now, have you ever seen a rectangle which has got sides negative 8 and negative 1? Not in this dimension. So whilst minus 3 is a solution to the equation, it's not a solution to the problem. So we need to cross that one out and say no, not a valid solution. Okay, so our only valid solution is the one that is 1/6. So the solution is x equals 1/6. Okay, so if you have got a quadratic and it's a problem like that, just check your answer is going to be sensible in the shape and space problem. Okay, because not every solution to an equation is a solution to the problem. Next up, we're looking at indices. So you need to know all your laws of indices here, don't you? So if you've got two numbers with the same base multiplied together, we add the indices. If you've got two numbers with the same base that we're dividing, we subtract the indices. If you've got a number and then you raise it to another power like this, an index of an index, you multiply those indices together. Okay, they're the three main rules. Plus on top of that, you need to know what a negative index means, that a to the minus n is equal to 1 over a to the n, and you need to know what a fractional index is. So a to the power of 1 over n, that is the nth root of a. Okay, so that is the kind of assumed knowledge for this topic. So you need to know all that. That's a bit chunky. Let's just try that again. Woo! Okay, rainbow pen. So yeah, that's the info we need for this topic. Let's go through the questions. Question 24. Work out 3 to the 12 divided by 3 to the 7. I've got numbers with the same base. It's that second rule, isn't there? I'm going to have to then subtract the indices. So 3 to the 12 divided by 3 to the 7. That is going to be 3 to the 12 minus 7. That's going to be 3 to the power of 5. Now it's asking us for an answer as a whole number here. So I'm going to have to evaluate 3 to the power of 5. It's quite a lot of work, isn't it? So 3 to the power of 2 is 9. to the power of 3, if we're going to cube it, we're going to get 27. Times it by another 3, it'd be 3 to the 4, that's 81. And times that by 3, that's 243, isn't it? So that's my answer, 243. Question 25, work out the value of 3 to the 12 divided by 3 to the 5 divided by 3 squared times 3. Ooh, this is not very nice. I think I might write this first bit as a quotient. So that's 3 over 12 divided by 3/5. And then I want to divide it by 3 squared times 3. Let's just tidy that up a little bit. So 3 to the 12 divided by 3 to the 5. That's going to be 3 to the 12 take away 5. That's 7. Divided by, and then I've got 3 squared times 3. That's 3 cubed. Just combining those two together. And then I've got 3 to 7 divided by 3 cubed. So same basis, subtract the indices. That's 3 to the 4, isn't it? Now we need the value here, so let's evaluate it. 3 to the power 4. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the value of that is going to be 81. Question 26. Simplify 8 times 2 to the 6 times 2 to the power 4. Give your answer as a power of 2. Well, that first number there, 8, that's a power of 2, isn't it? 8 is 2 cubed. So I'm just going to replace that as 2 cubed to start with. And then I'm going to, when I've noticed that I've got same base, 2, 2, and 2. So I'm going to add the indices, 3, 6, and 4. Add those together. So 3 plus 6 plus 4, that sums to 13. So that's going to give me 2 to the power of 13. Okay, 2 to the power of 13. Question 27. Work out root 3 times root 12 times 5 to the minus 2. Give your answer as a decimal. Well, this looks almost like a Surds question rather than a index question. Root 3 is root 3. Root 12, though, I can break down. Root 12 is 4 times 3, isn't it? Root 4 times 3. And the root 4 is 2. 5 to the minus 2 is 1 over 5 squared, isn't it? So then I've got root 3 times, well, root 4 is 2, so that's going to be 2 root 3, and that's divided by 5 squared. But root 3 times root 3 is 3, so the root 3 times 2 root 3 is going to be, root 3 times root 3 is 3, times 2 is 6, so it's going to be 6 over 25. Okay, and that's my final answer. No, it isn't, because that's not a decimal. If I want to get that into a decimal, if I times top bottom by 4, I'm going to get 24 over 100, and then that as a decimal is going to be 0.24 then, isn't it? Question 28, work out the value of 5/7 to the minus 2. Give your answer as a mixed number. Okay, negative index means 1 over the same number to a positive index. So what I can do here is I can just flip the fraction over and say that's the same thing as 7 over 5 to the power of 2. Okay, that's the easiest way of doing it. Because 5/7 is 7/5 to the minus 1. Okay, and then multiply minus 1 with minus 2, that gives you 2. So if you've got a negative index of a fraction like that, you can just flip the fraction over and change it to a positive index. So 7 squared is 49, 5 squared is 25. Mixed number, so 25s into 49 go once, remainder 24, don't they? So that's equal to 1 and 24 25ths. Okay, so 1 and 24 25ths. 29, work out the value of 2 to the power of 14 divided by 2 to the 9 raised to the power of 2. Okay, so I've got an index and an index here. I'm going to deal with that first. So 2 to the 9 raised to the power of 2, that is 2 to the 9 times 2. It's going to be 2 to the 18. So I've got 2 to the 18, which is being divided into 2 to the 14. Got two numbers with the same base, subtract the indices. 14 subtract 18, that is 2 to the minus 4. Now we need to write this as a fraction in its simplest form. So something that's got to the power of negative a number is going to be the reciprocal of that number with a positive power. So I'm going to get 1 over 2 to the power of 4. And 2 to the power of 4 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So as a fraction, it's going to be 1 over 16. Part B says work out the value of 25 to the power of 3 over 2. So I've got a kind of a fractional index here. I've got a numerator and I've got a denominator. Now you can treat these as two separate processes. So I'm going to do the denominator first, denominator of 2, that means the square root of 25. So what I'm going to get is the square root of 25 cubed, because I haven't dealt with the 3 part yet, the numerator, so just leave that there. I work out what the square root of 25 is, that's 5, and then I can apply the cube. So 5 cubed, that's 125 then, isn't it? Similarly, work out the value of 9 to the minus 1/2. Now again, I can treat this as two separate things, the negative symbol and the square root symbol. So a negative index means 1 over the positive index, so that's the same thing as 1 over 9 to the power of a half. And then power of a half, that's a square root, isn't it? So that's the same thing as 1 over the square root of 9, and the square root of 9 is 3, so that's going to be 1/3. So that's my answer, 1/3. Question 31, work out the value of 64 to the power of 2/3. Again, I'm going to treat these as two separate operations. I'm going to find the cube root and then I'm going to square my answer. So what is the cube root of 64 then squared? That's going to be, well, the cube root of 64 I know is 4, because 4 times 4 is 16 times 4 is 64. So that's going to give me 4, and then 4 squared, that's 16 then, isn't it? Moving on to cumulative frequency, here is some information about the test marks of 120 students. Now the first table is just a frequency table. It's drawn sideways, but it's a frequency table. And the next table is a cumulative frequency table. Again, drawn sideways, but it's still a cumulative frequency table. It just takes up less space if you do it that way. Now, first cumulative frequency is always the same as the first frequency. The next cumulative frequency is going to be all the values up until that point, isn't it? It's going to be the 20 and the 40 and the 28 added together. That gives you the 48. Then the next value is going to be those three numbers added together. Well, I already know the 20 and the 28 give me 48, so adding another 40 on, that's 88. So that's going to be 88. And then next cumulative frequency is going to be those, so adding the 20 on to 88, that's 108. And then the last cumulative frequencies, all of them added together, that is 120. Now your last cumulative frequency, the 120, should match the question up here. If it doesn't, you've made a mistake. Okay. Right, now once I've got my table of values, I could then plot those on the graph. Now you always get like a bonus point that you can plot here, this lowest value here, we plot against 0. So I'm going to have a point at 0, 0. So I'm going to plot a point here at 0, 0. And my next point is going to be the upper class bound versus the cumulative frequency. So I'm going to do 10 versus 20. So 10 along, 20 up is there. My next one, upper class bound against cumulative frequency, so 30 and 88. Now this scale, 5 boxes spans 20 units, so each little box is going to be 4, isn't it? So 88 is going to be 2 little boxes above 80, it's going to be there. 108, again that's going to be 2 little boxes above 100, and 120, that's up there, that wasn't too hard to plot. Okay, now join it with a nice smooth, typical S-shaped cumulative frequency curve. Okay, single line. Make sure you skewer each of your points. Make sure you don't feather. Okay. I think I went a bit low on that last bit. Let's just do that bit again. Okay, topping out with your last point there. Now it doesn't have to be Michelangelo, but it does need to be a single line, non-feathered, and skewering each of your points one after the other. If you miss the point, then you will miss a mark. Okay. Right, have we got any questions on this? Yes. Students who scored 15 marks or fewer take another test. Use your graph to estimate the number of students who take another test. Well, 15 marks is here. Look, that's 15 marks. So what we're going to do is we're going to use our ruler. We're going to read up to the graph and then across, and then that is going to be our cumulative frequency. So these people here, reading across. I do recommend you drawing these things on the graph. It's like your method. It's always good to show method. So each one of those little squares was 4, wasn't it? So it's 4 less than 40. That's going to be 36. So the students who scored 15 marks or fewer, how many were there? There were 36. Okay. Oh, I just noticed I've forgotten to plot a point there. I should have plotted the point 20 at 48. So, oops. I should have had a point here. Okay, so me bad. When you do it, make sure you plot all the points. Right, next one up, I've got here is some information about the miles per gallon of 60 cars. So we've got miles per gallon and frequency. We're going to have to first find the cumulative frequencies ourselves here. So this is going to be x again here, and this is going to be the cumulative frequency. So this one we're going to have less than or equal to 50, less than or equal to 60, less than or equal to 70, less than or equal to 80. So you'll notice I'm using the right hand limits here. Okay. Cumulative frequency, just add them up there. Our first frequency is our first cumulative frequency. Our next cumulative frequency is those two added together. 6 and 16 makes 22. Then add on the 28, that's going to take me up to 50. And then add on my 10, that takes me to 60. Just double check I get the same number as I should have. Yes, I do. Okay, now I can go on and plot the point. Now remember, I can use a bonus point down here. So I'm going to plot 40 against 0 on my graph on this one. So at 40, let me see both the things together so I can plot them. So I'm going to have a 0 point at 40. Okay, and then 50 goes with 6. So again, I've got 5 divisions representing 10 units on my scale. So 6 is going to be 3 little squares up, isn't it? It's going to be there. 22 for 60. That is going to be 1 square above 20. 50, that's a nice easy one to plot. And 60, that's a nice easy one to plot. Again, nice smooth, kind of distinctive S-shaped cumulative frequency curve. Topping out at that top number. It should kind of be flat at that top number there, because that is the total. It shouldn't be angled up. It should be kind of flat at your upper value, and also kind of flat at your lower value down there. That's what gives it its kind of S shape. Okay. Do we need to use this? Yes, we do. Use your graph to work out the interquartile range. Now, interquartile range is the upper quartile Q3 minus the lower quartile Q1. Now, the upper quartile lies 3/4 of the way through our data set, and the lower quartile is 1/4 of the way through. Now, I've got 60 people on this table, so a quarter of 60 would be 15. So my lower quartile I'm going to find by reading across from 15 and down. Okay, so 15 is going to be halfway along that square, isn't it? Going through the middle of that square. So reading across at 15 to my graph, and then changing directions and reading down. It's going to give me Q1. Okay, so that's Q1 there. And then Q2, it's going to be 3/4 of the way through. So 3 lots of 15, that's 45. So reading across from 15. Oh, it won't draw there. Okay, there. Done it now. Then reading down. Again, using this method to mark your axes, like mark your graph like this, is a good way of showing method. So the interquartile range then is going to be the value we got at Q1, not 15, but the value we look up at 15. I make that 56. So that's the Q1 value. So that's going to be 56. And then my Q2 value, what's that? That's 68. 68. So my interquartile range is going to be 68 minus 56. I make that 12. Now again, yours may vary slightly on how you've drawn your cumulative frequency curve, so you might not get exactly 12. Don't worry, the examiners will mark your graph, your numbers correctly if you've done it correctly. Okay, but you drawing a graph, there's always a slight wiggle to it, so you might get like a value either side of my 12. Okay, recurring decimals. Express 0.15 recurring. Sorry, it's a really warm day today. I've got the door open and my neighbours are taking at the hedge with something very loud. Do excuse me, but I can't close the door because it's sweltering. So express 0.15 with a dot on top as a fraction in its simplest form. So I'm going to let that be equal to x. X is equal to 0.1. I'm just going to draw some of these 5s in so I get a feel for the number. Okay. Now if I multiply that number by 10, I'm going to get 10x, and that is equal to 1.555555, and so on forever. Okay. Now if I then subtract one from the other, okay, so 10x minus x, that's 9x. And if I subtract the numbering parts, look, all these 5s cancel each other out to there, and then I've got 1.5 minus 0.1 left, haven't I? So 1.5 minus 0.1, that is just 1.4. So I've got 9x is equal to 1.4, so x must be equal to 1.4 over 9. Now we don't tend to write fractions with a decimal point in there, so if I multiply top and bottom through by 10, just to kind of get rid of that decimal point, shift it along one, that's going to give me 14 over 90. Does that simplify? Well, they're both divisible by 2, so I guess that's the same thing as 7 over 45. Go any further? Nope, don't think so. 7 has only got factors 1 and 7 does not go into 45. So that is my most simple answer. 7 over 45. Similar question here. Convert 0.28 reoccurring to a fraction. Give your answer in its simplest form. Again, I'm going to start off with x, and that's equal to 0.288. I'm going to show some of the 8s and so on. And now if I multiply it through by 10, I'm going to get 10x is equal to 2.88888 and so on. If I then subtract one from the other, then you can see that all these cancel by 8s, and it leaves me with a 2.8 take away 0.2, and 2.8 take away 0.2 is 2.6, and that must be equal to 9x. Dividing both sides through by 9, I'm going to get x is equal to 2.6 over 9, which is the same thing as 26 over 90, which is the same thing as 13 over 45, and that is as far as I can get, 13 over 45. Moving on to surds. Now you need to know how to combine, to simplify, and to rationalize surds. If you can do all those three things, you should be good for these questions. Question 36. Work out the value of root 3 squared times root 2 squared. Well, when you square a square root, you just get your original number back, don't you? So root 3 squared is just 3, and root 2 squared is just 2, and 3 times 2 is 6. That's not so hard, is it? So it's 6. Question 37, work out root 5 squared plus root 6 squared minus root 7 squared. That's the same question, isn't it? So that's going to be 5 plus 6 minus 7. Is this a higher question? Look at that, that's so easy. So 11 take away 7, that's 4. Okay. Question 38, show that 14 over root 7 can be written as a over root b. So this is an example where we have to rationalize the denominator. We've got a surd as the denominator of our fraction. In maths, we kind of consider this to be a bit fugly, to be honest. Hard to imagine fractions which have got surds as the denominators. You know, if you had a 7th, you could imagine a pizza divided into 7 lovely pieces, but can you imagine a pizza divided into root 7 pieces? I would struggle. So yeah, it doesn't make a lot of sense, so we don't like them as mathematicians to have surds as our denominators. So when we see them, we get rid of them. Get rid. Okay, so and we do that by multiplying top and bottom by that denominator, and that has the effect of rationalizing the denominator, because root 7 times root 7 is 7. 14 root 7 goes on the top, 14 root 7. So it's 14 root 7 over 7. Now you'll notice that 7 goes into the 14, so you can cancel that out. So that divides into that, leaving you with 2. So my final answer then is going to be 2 root 7, which is in the form a root b as required. Okay, where a is 2, b is 7. Question 39, work out root 18 minus 28 over root 50. Now we have to do two things here. First off, we need to simplify that root 18 because we can write it in a more simple way, and we have to rationalize the denominator of the second part of the fraction. Now if you like, you can do that separately and recombine. That's one way of doing it if it's difficult to manage everything. So we can work on this in two parts. If we work on the root 18 part first, we can say, well, root 18, that is the same thing as the root of. When you're simplifying these, you're looking for factors of your number that are also square numbers. So think about the square numbers 1, 4, 9, 16, 25. Can you think of any of those numbers being a factor of 18? Well, 9 is, isn't it? 9 times 2 is 18. And the reason why you're looking for square factors is that you can then square root your squares. Square root of 9 is 3, so that's the same thing as 3 root 2. So you can break it into two different parts. You can square root the 9 part, get 3, and it just leaves you as 3 root 2. So we know root 18 is 3 root 2. We simplified that part. Now let's see if we can simplify the 28 over root 50. Now doing the same thing as with last question, multiplying top and bottom through by root 50. So that's going to rationalize your denominator. Root 50 times root 50 is 50, and that's going to give me 28 root 50 on the top. Now root 50 might also simplify. I can certainly divide 28 and 5 by 2. That's going to give me 14 over 25, isn't it? 14 and 25, I've divided both by 2. But root 50 can also simplify as well, because 50 has got a square factor of 25. So I can rewrite that as 14 root 25 times 2 over 25. And 25 rooted is 5. So that's going to be 14 times 5 root 2 over 25. Now, rather than multiplying the 5 with the 14, I've seen it can cancel into the denominator, give me 1 and 5. So that's the same thing as 14 root 2 over 5. Okay? So now I've got both of my surds simplified down. So this part here, root 18, I can write as 3 root 2. And this part, 28 over root 50, I can write as 14 root 2 over 5. Okay, so now I can recombine them. I can then say then root 18, which I know is 3 root 2, and I'm going to be minusing 14 root 2 over 5. Okay, so factorize. I could factorize out the root and then just deal with the fractional part and then put it back, or I could just work on the two fractions and work out what that is and write it at the front. What should we do? Let's do it properly. Let's factorize out the root 2 and think about what is 3 minus 14 over 5. Let's just do that bit. So what's 3 minus 14 fifths? Well, 3 is 15 fifths. So 15 fifths minus 14 fifths, that's 1/5, isn't it? Okay, so I'm going to get then that is equal to 1/5 of root 2, or root 2 over 5. Okay, so that's what it simplifies down to, root 2 over 5. Question 40, root 150 minus root 6 over root 2 times root 3 simplifies to an integer. Does it? Let's find out. Well, again, looking for square factors, I'm seeing 150 and I'm thinking 25 is a nice square factor of 150. 25 times 6 is 150. Okay, and I notice I've got a root 6 in the other part there as well, so that's kind of handy. So what we've got then, so root 150 is 25 times 6, so that becomes 5 root 6 on the top, and I've got that minus root 6 there, and then I've got root 2 times root 3. Well, root 2 times root 3 is the same thing as root 2 times 3. 5 root 6 minus root 6. If I've got 5 root 6 and I take a root 6 away, I'm left with 4 root 6. So 4 root 6. And root 2 times 3 is the same thing as root 6. So I've got 4 root 6 divided by root 6. So I can cancel that with that, and lo and behold, it leaves us with an integer, which is 4. Okay. Question 41. Work out the value of 5 over root 3 minus the square root of 6 3/4. Give your answer in the form k root 3. Okay, I think I'm just going to do the same thing as I did earlier. I'm going to work on those two separately first, and I'm going to bring them back together again, reunite them after I've simplified them down a bit. So let's start with 5 root 3. Rationalising the denominator, multiplying everything through by root 3 over root 3. That's going to make the denominator 3 on the bottom, and I'm going to get 5 root 3 on the top. Okay, so that's going to be my new yellow bit. Now the green bit, root of 6 3/4. 6 3/4, a mixed number. That doesn't look right, does it? So let's turn that into a top-heavy fraction first. 6 times 4 is 24, plus 3 is 27. So that is 27 over... So 6 3/4 square root. It is the same thing as 27 over 4. Okay? So, when you're square rooting a fraction, you can square root both parts separately. That's the same thing as root 27 over root 4. Root 4 is 2, so I've got root 27 over 2. Now, 27 has got a square number as a factor, which is 9. 27 is 9 times 3. So I can say that that's the same thing as the square root of 9, 3 times root 3 over 2. Okay, so that's my green bit. That's about as simple as I'm going to get that one. So I've got my yellow bit. Let's recombine them then. So starting back with what I started with, so 5 over root 3 minus the root of 6 3/4. That's equal to the yellow bit then, 5 root 3 over 3 minus the green bit, which is 3 root 3 over 2. Got fractions with different denominators here. If you want to subtract them, you need the same denominator, don't you? So you've got 3's and 2's here, so common denominator would be 6. So just multiplying top and bottom through by 2 for the first fraction. So times 2 is going to give me a denominator of 6. And if I times 3 and times 3 on the second one, I'm going to get 6. So that's going to be equal to 10 root 3 over 6 minus 9 root 3 over 6. So 10 root 3 over 6 minus 9 root 3 over 6, they've got the same denominator, so I'm going to put them over one denominator then. So that's 10 root 3 minus 9 root 3 all over 6. Well, 10 root 3 minus 9 root 3, if I've got 10 root 3's and I take 9 of them away, I'm just left with 1 root 3, aren't I? So that leaves me with root 3 over 6. Okay? Is that in the right form? Well, I've got it as root 3 over 6. I could just write it as 1/6 of 3. It doesn't say that k has to be an integer, so I can just write it as a 1/6 of root 3, just to get into the form that they want it to be in. Okay. Moving on to exact trigonometric values. These are the ones where you need to know the sine, cosine, and tangent of various angles. You need to know the angle of 0, of 30, of 45, of 60, and 90. And you need to know that for sine, cosine, and tangent. Okay? Now, the easiest way to remember it is in a kind of a simplified version of these values, but if you do it this way, you might have to simplify them a little bit more after you write them down. Okay, because it's an easy way to remember, but you've got to do a little bit more work to find the final surd sometimes. Okay, so what I do is I just take the numbers root 0, root 1, root 2, root 3, root 4. Can you remember that? 1, 0, 1, 2, 3, 4. And put a root sign over it, and then put all those over 2, over 2, over 2, over 2, over 2. They're your sine values. Okay. Now your cosine values, kind of give myself a bit more space. Cosine values are going to be the same values, but the other way around. So rather than starting with root 0, I'm going to start with root 4. So root 4, root 3, root 2, root 1, root 0, over 2, over 2, over 2, over 2, over 2. They're my cos values. And then finally tan. Tan, you take the sine, the numerator of the sine, and you divide it by the numerator of the cos. Okay? So root 0, over root 4, root 1 over root 3, root 2 over root 2, root 3 over root 1, root 4 over root 0. Now, some of these values then simplify further, okay? I'm not going to do all of them. I'm just going to pick out the ones when I need them and simplify them as I go through, and I'll show you. Because obviously, look, root 1 is just 1, and I've got root 2 over root 2 somewhere. That's just going to give you 1. So a lot of these things just simplify down. But that's how I remember it. Super simple way of remembering it. And then I just kind of simplify it as I pull them out of the table as I need them. Okay, right, so question 42, circle the value of cos 30. So straight from my table, I can see that the value of cos 30 is that one, isn't it? Root 3 over 2. Okay, so I've kind of scored all over my question paper here, but it's that one there, root 3 over 2. Question 43, show the value of cos 30 times cos 60 plus sine 30 is an integer. Well, cos 30 is the one I just had. That was root 3 over 2. I'm going to times it by the tan of 60. Tan 60 on my table says root 3 over root 1, but I know that root 1 is just 1. So that's the same thing as root 3 over 1, or just root 3. So this one simplifies down to root 3. So that is root 3. And then plus the sine of 30. So in my table, I've written root 1 over 2. Well, root 1 is just 1. So that's the same thing as 1 over 2. It's just a half. Okay, so that gives me a half. Okay, so this is what I mean about simplifying these values as you pull them out and use them. Okay, so I've got root 3 over 2 times root 3 plus half. Well, if I've got root 3 over 2 times root 3 over 1, that is root 3 times root 3, which is 3, over 2 times 1, which is 2, plus a half. So what's 3 over 2 plus a half? Well, that's 4 over 2, isn't it? Or just 2. So it's an integer. It is an integer, it's 2. Question 44, show that the value of 5 sine 30 times cos 30 times 8 tan 30 is an integer. Okay, so I remember from the last question, sine 30 was a half, and cos 30 was root 3 over 2. What's the tan of 30? Let's go back up and look at the table. Tan of 30 is this one here, look, root 1 over root 3. Well, the root of 1 is just 1. So that's going to be times 8 times root 1, which is just 1 over root 3 down there. Okay, so I need to show that this is an integer. Now, I've got things on the numerator. I've got 5, a 1, a root 3, an 8, and a 1. And I've got things on the denominator. I've got a 2, and a minus 3. Now, I can cancel anything in the denominator with anything in the numerator. That's how maths works, isn't it? So I'm going to cancel that root 3 into that one, because root 3 divided by root 3 is 1. I can cancel that 2 into the 8, giving me 4 and 1. And I can cancel that 2 into the 4, giving me 2 and 1. Okay, so now I've simplified all my denominators down to 1. 1 times 1 times 1 is 1. And I've simplified a lot of my numerators as well. So now I've got 5 times 1 times 1 times 2 times 1. I make that 10. 10 over 1, which is just 10. The answer is 10. Question 45, angle x is acute, cos x equals sine 60 times tan 30. Okay, so remembering earlier, sine 60 is root 3 over 2, tan 30 was 1 over root 3. So multiply those together, and that's going to give me cos x. So cos x is root 3 over 2 times 1 over root 3. Now again, I could see that cancels with that. That leaves me with a half. Cos x equals a half. Work out the sine of angle x. Well, coming back to my table, which angle has a cos of a half? Well, it's that one there, isn't it? It's root 1 over 2, that one, because root 1 is just 1 over 2. So if cos 60 is a half, that means that x must be 60. X is 60, because it's the cosine of 60 that has a value of a half. Okay, x is 60. Work out the value of cos 30 times the sine of 45 times the tan of 60 all squared. Okay, so I can remember cos 30 is root 3 over 2. Sine 45 was, what was the sine of 45? That was root 2 over 2. So times root 2 over 2, and the tan of 60, that was root 3 over root 1, which is just root 3. So times root 3, and then we're squaring that. Okay, so again, I've got some things on the numerator. I've got root 3, I've got root 2, and I've got root 3, and I've got some things on the denominator, 2 and 2. So combining the numerators, root 3 times root 3 is 3, times root 2, that's 3 root 2. So my numerator becomes 3 root 2. My denominator is 2 times 2, which is 4. And I need to square all that. Okay. Now when you're squaring things multiplied or divided together, that square gets applied to each part. So it gets applied to each 3 of those parts separately. So I'm going to be squaring 3. That's going to give me 9. I'm going to be squaring root 2. That's going to give me 2. And I'm going to be squaring 4. That's going to give me 16. Okay. So I'm going to get 9 times 2, which is 18, divided by 16. That's the same thing as 9 over 8. Okay, or 1 1/8, but I'm happy with it being 9 over 8. Final section, algebraic fractions. Show that 2x plus 1 over 3 plus 5x minus 2 over 2 simplifies to 19x minus 4 over 6. Now the thing to remember about algebraic fractions is that they behave exactly the same way as fractions. Okay, so what you do with fractions, if it was a number, that's what you do with fractions if they're algebraic. You do the same thing. So here, if I've got two fractions with different denominators, I have to make the denominators the same. So if I've got 3 and 2, the common denominator is 6, isn't it? So how do I change them into 6? Well, 3 goes into 6 2 times, so multiplying top and bottom through by 2, basically, aren't you? So 2 times 3 is 6 on the bottom. 2 lots of 2x plus 1. That's going to be 2 lots of 2x plus 1, like that. Okay, and then 5x minus 2. Well, 2 goes into 6 3 times, so I'm going to multiply this by 3 and this by 3 to get 6. So on the top, I'm going to get 3 lots of 5x minus 2. Okay, so putting that over one denominator and multiplying out the brackets. So I've got 2 lots of 2x and 2 lots of 1. That's going to give me 4x plus 2. And I've got 3 lots of 5x and 3 lots of minus 2. So that's giving me 15x minus 6. Okay, collecting like terms, I've got a 4x and a 15x. And I've got a 2 and a minus 6. So that is 4x plus 15x is 19x. And 2 and minus 6 is minus 4. So I'm getting 19x minus 4 all over 6. Oh look, that's the same as that one. I did it. Question 48, simplify fully 6 over a minus 11 over 4a. Okay, so what's the common denominator out of a and 4a? Well, 4a is 4 times bigger than a. So if I multiply top and bottom through by 4, I'll get 4a on both of them, and then I can just do the subtraction then, can't I? Okay, so that's the same thing as 4 times 6, that's 24 over 4a minus 11 over 4a. Now I've got the same denominator, I can just simply subtract the numerators. 24 take away 11, that's 13. So I'm just going to get 13 over 4a. That's my final answer, 13 over 4a. Question 49, simplify 4x squared minus 1 over 4x squared plus 12x plus 5. Now with these ones, you tend to look to factorise top and bottom and then see if you can cancel any of the factors out and simplify it that way. On the top, I've got 4x squared minus 1. Now that is a difference of two squares again, haven't I? I've got a square and a square. 1 is a square, 1 squared is 1, and I'm subtracting them from each other. Okay, so the top half is a difference of two squares. So using our identity a squared minus b squared is identical to a plus b, a minus b. All we need to do then really is square root those two squares and write them in that form instead. So that is going to be equal to square root of 4x squared is 2x, square root of 1 is 1. So I'm going to get 2x plus 1, 2x minus 1 on the top. On the bottom, I've got 4x squared plus 12x plus 5. Now if it factorises, it's going to factorise into two brackets, but annoyingly, it's got a lead coefficient of 4. So it could be 4x and x, or it could be 2x and 2x. Now, because of the nature of the question, I'm suspecting it's the second one, so we can cancel some of the 2x plus somethings with the 2x plus somethings underneath. So I'm beginning to think it's probably not that one. It's going to be the one at the bottom one. The number ends in 5. Only one factor pair of 5. That's 1 and 5. That makes things easier. So if I did have a 1 and a 5 here, does it work? So 2x times 5 is 10. 1 times 2x is 2. 10 and 2 is 12. So that does work, doesn't it? So it does factorise like that. So I'm going to get 2x plus 1 and 2x plus 5. Now notice, look, I've got a 2x plus 1 on the top and a 2x plus 1 on the bottom. And when you divide things that are the same, they just cancel each other out. Only works if they're factors. Here they're factors. And that leaves me with 2x minus 1 over 2x plus 5. Okay, that's as simple as this one's going to get. We're done. Question 50, simplify fully y squared minus 3y times y squared plus 10y plus 21 over y squared minus 9. So again, I have got on that fraction on the right hand side, I've got a quadratic on the top and I've got a difference of 2 squares on the bottom. So I'm just going to leave the first part as is at the moment. No, I'm not. I'm going to factorise out a y. So I think I'm going to factorise out a y out of the first part, make it y times y minus 3. And then the second bit of the fraction, I'm going to factorise into 2 brackets on the top by factorising the quadratic. And I'm going to factorise the bottom as well using a difference of 2 squares. Difference of 2 squares is easy, and we do that first. Y plus 3, y minus 3, super simple. Then the other one, I've got 21 on the end, factor pairs of 21, 1 and 21, 3 and 7. I'm suspecting 3 and 7 because it adds up to 10. So that is y plus 3, y plus 7. Okay. Oh, look, brackets that cancel. Those two go. Oh, but also brackets that cancel. There you go. And that leaves you with y and y plus 7 in the numerator. So that is all equal to y plus 7. Now, I think that is as simple as it needs to be. You could multiply it out and get y squared plus 7y. I'm not sure that's any simpler than you had already, though. Different versions of the same thing. I'd be quite happy to leave it like that. Question 51. Again, I've got a difference of 2 squares on the top. I've got a quadratic underneath, and I've got 2 factors, top and bottom, in the second fraction. This time, look, though, I've got a divide. But I can keep change flip on this, isn't it? KCF. Keep the first fraction the same, change the divide to a times, and flip the second one over. Okay, so first fraction, difference of 2 squares on the top, that's going to factorise into 2 brackets. I've got a quadratic underneath that hopefully factorises into 2 brackets. I'm going to change the divide into a times, and I'm going to flip those 2 factors and the last fraction over like that. Okay, and then again, hopefully I've got some bits that cancel a bit further down the line. Right, so I've got 9x squared minus 1. Okay, so the square root of 9x squared is 3x. So I'm going to get 3x and 3x. Square root of 1 is 1, so plus 1 minus 1. That was easy. 3x squared plus 2x minus 1. If it factorises, it's going to have 3x and x there, isn't it? Okay, got 1 at the end, so it's going to have to be 1 and 1. How do the signs go? If I make this one positive, that's going to give me plus 3x, and minus x will give me the plus 2x in the middle. Okay, that all seems to work. Now, what have we got that matches that we can cancel? Well, I've got a 3x minus 1 on the top there, and a 3x minus 1 on the bottom there. I've got a 3x plus 1 on the top here, and a 3x plus 1 on the bottom here. And that just leaves me with x minus 2, x plus 1 on the top and bottom. So x minus 2 remains. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.